wait, let me do an engineering term. It's 651.04 times 10 to the power minus 6. So it's very small, okay? So I'm going to ignore it. I'm going to ignore the yellow term. So 4 times by 1 over 8 times by 3 squared. Okay, so you have 9 over 2, not 9 over 2 times 2 is 9 plus by 10 power 3 times by 1 over 8 divided by 12 plus by 125 over 12. Okay, so now so let me do it again. 4 times 1 over 8 times by 3 squared times 2 is 9. 1 over 8 times 10 power 3 divided by 12 is 125 plus 9. So this will be equal to 233 over 12 inch to power 4. Okay. So so this value over here, because it's t cubed, this is not included. Okay, I took it out. Okay. So now we found our today I'm kind of tongue tied. We found our IZZ. Okay. So from here, we want to find our F1. Okay, we want to find our F1 and F3 now. Okay. So this is our F1. This is our F3. Okay. So we are going to look at section. So we know that F1 is equal to F3. So we will look at the section BD. Okay. So as we have constructed, these are all our terminals. So this is our direction of Z, right? So we're going to find Q BD first. So our width is Z, our thickness is T, our Y bar is 3. Okay. So this 3 Z T, right? Then we substitute into B D as a function of Z. So this will be equal to V over I T and 3ZT. Okay. So we have 3VZ over I. Okay. And then we found out what our I is. So 3VZ, our I come in to be what? Our I is 233 over 12. Okay, 233. So this will become 36 VZ over 233. Okay. Then the same thing, we have our forces for BD. David, should the 4 be a 4 minus 1 over 16 since it go to the middle of AG? No, you just take when we analyze, we just take the center line. Okay, we just take the center line like this. Okay. Okay, David or Devin, sorry. Okay. So from Devin, is that okay for you? We just take the center line only. We ignore the thickness, Devin. I do apologize seeing your message a bit late. Okay. Okay. I think Devin is not okay, but he did not say anything. I'm going to move on. So we know that F1 is going to be equal to F3. We're going to integrate from 0 to 4, right? Here, BD is a function of Z, T, dz. Okay. So when we substitute in 0 to 4, we have 36 Vz over 233. Then we have T dz. Okay, Devin is okay. So this will be equal, again, very simple math. V T, right? Then we have 0 to 4, 36 over 233. Okay, then we have Z dz. So B T, then we have 36 Z squared over 466, 0 to 4. Then we, over here, you substitute your 4. So 36 times 16 divided by 466 is equal to 288 over 233. So we are almost there now, okay? Then now we are going to take moment. And let me get this diagram. This is our point C. We found our F1. And I think I call that one our F3. Okay. So from here, we are going to take our moment. Rotation in the X at point C is equal to 0. So we know that it's going to be going in a anti-clock. The F1 and F3 is going to go anti-clockwise in terms relative to point C. So it's twice of VT multiplied by 288 over 233 plus VE. The whole thing will be equal to 0. Okay. So when we have our V is equal to 288 over 233, it's equal to 576 minus 576 over 233, and this is our VT. So E is equal to minus 576 over 233. Thickness is 1 over 8. So 576 over, hold on, I think I did something wrong. I'm missing my perpendicular distance. So 2 times 3, okay, that is 2E. So I have to multiply 3 on this side. Today is just not a good day for me. So 576 over 233 times 3. I forgot about the perpendicular distance. My bad. Okay, so 1728. Did anyone highlight that? There you did. Over 233. Okay, so you guys are not like me. You guys are still awake. Multiplied by 1 over 8. So it is minus 1728 over 233 times by 1 over 8. So my answer is 0. Minus 0.927 inches. Okay. So now once you put value in, is easy to understand what's going on. Okay, 0.927. So once we get here, the next part of the question, so far, are you all okay? Liu, yeah, I forgot about the distance. That's why I multiplied 3 over here, okay? I forgot about the distance initially. Okay, so the next part of the question, which is not necessarily more difficult, okay, but you have to be like really, really careful, okay? So the next part of the question asks us about the distribution. Okay, they ask us about the distribution. So they ask us about, we have to find the distribution at point A, point B, point D, point E, point F, and point G. Okay, so we have to be careful. Okay, so let's see what we have to find. Okay, so we have to find the shear stress distribution. So i.e., we have to find stress at point A, stress at point B, stress at point D, stress at point E, stress at point F, and stress at point G. I will also we have to include the maximum shear stress. Okay, we have to include that. Okay. So when we design our shear force or our F, right? These are our F. So I think I call this F1, F2, V. I could not remember which is F3. That's F3, and that's F4. Okay. So we realize that there are terminals over here. Okay, so this is one of our terminal. This is one of our terminal. So this is one of the terminal. So this is one. So as I said before, okay, at the terminals, right? The first moment of area is equal to 0. Okay, at the terminal, the first moment of area is equal to 0. So for this case, shear stress at point A equal to shear stress at point D is equal to shear stress at point E, and is equal to shear stress at point F. All of them are equal to what? 0. Okay. So I want to focus on, give me 2 more minutes. Okay, I know some of you have to run. So I want to look at point B now. So if we were to sketch point B, point B is over here. Okay. So if point B is over there, what are the values we are going to find? Okay. So as we imagine, point B can have 3 locations. Okay. Can have a location over here. This is also point B. Can have another location over here, or can have another location over here. There are 3 separate locations. Okay. So this one I call it flange. This one I'll call it web. This one I call it flange plus web. Okay. So I'll just show you one. Okay. So if we want to calculate the shear stress at point B, just at the flange. Okay. So the QB at flange is equal to width is 4, the depth is 1/8, the distance is 3. Okay, so 4 multiplied by 1/8 multiplied by 3 is equal to 3/2.
DJ, can I just interrupt for a second?
Yes.
Someone in the chat pointed out, why is the tau e at 0? Shouldn't it be
Oh,
tau
no, it's
g?
not. Yeah, it's tau g. Thank you. I got too excited again. So A, no, B is not equal to, hey, no. What am I doing? What am I doing? I'm still sleeping. It's the snow. Point A, point D, point G. Sorry, point G and point F. Yes. Rushing again. Okay. Give me 10 more seconds. So from here, your shear stress at point B flange is equal to, so V is equal to 2.75 times 10 to the power 3. Q is 3 over 2. I is, what is our I? Go on, my bad, okay? I is equal to 233 over 12. Right, I is equal to 233 over 12. Oi. By thickness 1 over 8. So this will be equal to 2.75. Power 3 times by 3 over 2 divided by 233 over 12 divided by 1 over 8. So it will be 1.699 or 1.7 times 10 to the power 3 psi. Okay, I'm going to stop here. Homework 6 has been posted. Okay, it's more longitudinal shear. And this coming week, okay, there will be no quiz. The next week, then you have quiz. So enjoy your reading week. I see you after your reading week. Thank you. I'll still stay behind if you have any question.
Eugene,